Welcome back to Industrial Automation course, Lecture 8, Programming Timers in CODESYS, practical session. Today's topics are as follows. Using timer on delay block in CODESYS, displaying integer values, time in milliseconds, in the visualization of CODESYS. Using timer off delay block in CODESYS, combining timer on delay and timer off delay blocks in CODESYS, using pulse timer block in CODESYS, and simulating typical processes in CODESYS. This session is a practical session. I expect students to have CODESYS already installed on their PC and following all the instructions of slides one by one. And at the end, they should implement and exercise programs. Timer on block in CODESYS. Create a new project and insert a contact with the variable name of a start. Okay, so here we have our contact start. Then insert a timer on block to the program. So here from the toolbox, you just need to drag and drop here. And once you do so, then you will see the detail of the timer on block. But here you just need to define the start as a Boolean in the variables, okay? You can change the name of the block or keep the default one using auto declare window. So once you drop it here, the auto declare window will pop up. The input of timer will be connected to the start contact. This input, you need to connect it to the input. You could either change the name of the timer or leave it as the default one, so it doesn't matter. And the type, you shouldn't basically touch the type because you need a timer on delay. As you declare the timer on delay variable, it will appear in the variable declaration window of the PLC program. So here we have the variable declaration window, and now you see that beneath the start you have the TON0 with the type of TON. Okay, so the type is TON. Set the preset value PT to 10 seconds. Okay, so 10 seconds, and declare the elapsed time variable for the elapsed time. So here you need to declare a new variable, elapsed time. Note that the type of the variable is time. Okay, so the type of the elapsed time is time. Insert a coil motor and connect it to the Q output of the timer. In the variable list, you should see the declared variables. So here you have our coil motor connected to the output Q of the timer. And once you do so, you see the Boolean variable of the motor, plus you already declared elapsed time as a time variable. So whatever you add to the program, you should be able to see in the variable declaration window. Add a visualization object to the project. So we had this discussion before, how you could add a visualization object. Yes, please follow the instructions of the previous slides. Insert a lamp and associate it with the motor. So in the variable, you need to associate it with motor. Insert a push switch and associate it with the start contact. This is the push switch and the start contact. Now log in and run the program and examine its operation. Okay, so you need to log in and run and see how the visualization or the program works. If you press the push button, how long does it take for the lamp to be on? And examine the performance of the program. Displaying the elapsed time in the visualization. So in the visualization, now we want to add a text field. Insert a text field from the command controls in the visualization. So here in the command control, text field, drag and drop it here, and then you have the text field. In the properties of the text field, in text.text, insert the following text: elapsed time, in milliseconds. Yes, so as in the quotation, you just need to enter exactly same as the expression in the quotation. Okay. In the text variable, the text variable here field, specify the elapsed time ET variable of the timer. So once you click here, then you could select the ET or any other variables. So select ET. Now you will see this expression here. Okay. Log in and run the project and observe the operation. Now insert timer off delay block in the program and connects its input to the same start contact. Okay, so keep this rung, add the new rung, and in this rung, add this timer off delay block. Drag and drop here, and then the auto declaration window will pop up here. Keep the type, choose whatever name you wish, and then press OK. The new variable should appear in the list of variables in your project. Here you have the new variable. Set the PT or preset time to 5 seconds. Define elapsed time of variable and set it for ET of TOF. Connect the output to the new coil motor 2. So you need to define or declare a new coil variable, a Boolean variable motor 2. Okay, so the one of them has preset time value of 10 seconds, the other one has preset time of 5 seconds. One of them is on delay, the other one is off delay, and both of them will be activated by the same start button. In the visualization window, insert the new lamp and assign it to the motor 2 coil, this lamp. Okay, so you're better off changing the color. Insert a new text field and assign the text variable to the ET variable of TOF here, okay, and use the same expression inside the text.text. Then log in and run the program and observe the operation of the program. Watch the variables for both TON and TOF blocks in the runtime. Okay, so observe the elapsed time, observe how these lamps will basically react to pressing and releasing this push button, okay, and understand the differences between the on delay and off delay timer. TP block in CODESYS. TP block is a pulse timer. okay, pulse timer. So it's different from on delay and off delay. The main idea of using it is to generate a pulse whenever there is a rising edge in the input of the block. So when the input goes from off to on, it will create a pulse for a specific duration of time. The length of the pulse can be determined using preset time input of the block. To insert a TP block in the model, start by using a box from the toolbox. Okay, so here, drag and drop a box. Then double click on question marks here inside the box to determine the type of the box. Okay, so you could use also the same method. So you could use a box for an on delay and off delay timer and choose on the TON and TOF variables, or for example up counters or down counters or any basically variables. You could use box, yes, but for TP block or a pulse timer block, it's easier to use this method. In the input assistant window, select TP from the timer category. Okay, so in the timer, you see once you have a box, you could select counter or miscellaneous type of variables or trigger or any other, yes, ones. But you go to the category of timers and then select TP. The specification of the TP is displayed in the same window. Here we have specifications of the TP. Specify a variable name TP underscore 0 and declare it using the auto declare. Okay, now you see we have a type of TP, and this is the name that you chose. For the contact connected to the input of the block, select the start contact. So we want to trigger it with the same input. Set PT to 7 seconds. Declare a variable for the elapsed time of the timer, elapsed time TP, and use a new coil motor tree in order to connect the output of TP Q. Okay, so the output of the pulse timer block will be connected to the motor tree. So this is a wrong tree or in the network tree. So far we have 3 wrongs. In the visualization window, insert a new lamp and assign it to the motor tree coil. Insert a new text field and assign the text variable to the ET variable of TP. Here, then log in and run the program and observe the operation of the program. Watch the variables for TON, TOF, and TP blocks in the runtime. Okay. So basically, this program helps you to understand how different timers work. Exercise 1. Combine TON and TOF blocks. Create a new project. The aim is to write the program in order to have a blinking lamp in the output whenever the start push button is pressed. By pressing the stop push button, the lamp should turn off. Create a visualization window as well. So we had a similar program, and we call it flasher or annunciators. You could use a quite same technique to combine TON and TOF block to have the blinking lamp. Create a TT output for TON and TOF timer. The TT is timer timing. As you have noticed, there is no TT output timer timing for the TON and TOF blocks in CODESYS. Use the inputs and outputs that you have access in order to create outputs similar to the TT output. Okay, so I expect you to accomplish this exercise and these projects and submit it to Moodle. Exercise 2. Traffic light control in one direction. Create the project and write the ladder logic program in order to have the traffic light control system working according to the picture on the right-hand side. Demonstrate the functionality of your program by showing the operation in the visualization. Use 2 sets of lights for the cars and passengers. Okay, so you have already the program, yes, so you just need to implement it in the CODESYS. Okay, and you should have 2 sets of lamps for the cars and passengers. Okay, so you may need to a little bit extend or change this program to include the passenger lights. Okay, again, same as exercise 1, I expect you to accomplish this program and submit it to Moodle. Exercise 3, traffic light control in one direction with passenger interruption option. Create a project and write the ladder logic program in order to have the traffic light control system for one lane street in which the green light is on for the cars all the time. Red light is on all the time for passengers. Okay, so the cars basically have right of way and they always could pass the traffic light. However, when a passenger presses a push button or activates a sensor, the amber light for cars will turn on for 5 seconds, and then the red light for cars, and then the green light for the passengers will be turned on for 20 seconds. Okay, so this is the interruption, passenger interruption option. If the passenger presses a button to pass to cross the street, then cars basically should be stopped first by red light, amber, and then red light, and then passenger light should turn on to green for 20 seconds. Afterward, the system will work in a normal way until another trigger comes from the passenger. Display the amount of time that the passengers need to wait or they have for crossing the street. Okay, so in this one should be done in the visualization, same as in many crossing lines. You could see that there is a display that shows how many times passengers have to cross the street. Yes, and it improves the safety. Again, same as other exercises, I expect you to submit the exercise and the program to Moodle. Exercise 4, retentive undelay timer in CODESYS. As you already may know, there is no retentive undelay timer provided by CODESYS. However, you can create your own as a function block. In the following video, you can see how to create a function block in CODESYS and use it within your code. In this exercise, you have to create a function block which behaves similar to a retentive undelay timer. Okay, so although this exercise done in this video, but I expect you to implement it on CODESYS and submit it to Moodle. So this is a practical session, and it is basically these are hands-on projects help you to improve your skills and understanding of timers. So please implement these exercises and submit them to Moodle.